What's up, y'all? This is section 6.52, Operations with Radical Exponents, Rationalizing the Denominator. Rationalizing the denominator is one of those topics that used to be way, way, way more important than it is now, mostly for calculator. Like, with the advent of the calculator, we don't really need to do this as much, but there are a couple of times in calculus and pre-calculus when you've really got to rationalize that denominator. So let's learn it here and now. Rationalize the denominator. In this case, if it's a monomial, we flip over to the next page or the second half of this lesson. It won't be a monomial; it'll be a binomial, and we have to do something a little bit more tricky. But right now, if it's just a monomial, here's what we need to do: rationalize the denominator. It just means get the square roots out of the denominator. It could also mean get rid of the i's that might be in the denominator, like the imaginary numbers. But in this case, if you start with 9 over square root of 3, what you really want to do is multiply it by a form of 1. That's going to be true and for all these problems. First step, multiply by a form of 1. It's going to make sure that you produce something you actually can take the square root of. You can take the square root of 9. So 3 times, what you need here is a square root of 3. Square root of 3 times square root of 3 is square root of 9. And in the denominator, look, and the answer over here is 3, because you can take the square root of 9 as 3. But you can't just multiply the denominator by something without also multiplying the numerator, and therefore you won't actually change the value of what's going on. It'll just be, you're multiplying it by a form of 1, which is great. So it's going to be square root of 3 in the denominator, and therefore square root of 3 in the numerator. 9 times square root of 3 is just 9 root 3. And so then once you get this, you can actually take it one more step and simplify, because 9 over 3 turns into 3. So the answer really is 3 root 3. This is a rationalized denominator. There's actually no denominator here, or you could say the denominator is 1, which is a rational number. No square roots in the denominator is the big deal. So let's get the square root out of this denominator here. Again, if we multiply the square root of 7 times square root of 7, we produce something that actually we can take the square root of. You can take the square root of 49, and so therefore we're going to do that to both the denominator and the numerator in order to not change the value of the fraction. So 7 times 7 is 49, and you can take the square root of 49 and it's 7. But 7 times 3 is 21, and that is what your new numerator is going to be. Move my head over here. Great. Square root of a fraction here. Square root of 6 over 7. Well, I just think it's a lot easier if you break it up into numerator and denominator, that we can think about them individually. So square root of 6, this square root of this fraction becomes a square root of 6 over the square root of 7. A lot easier to deal with, because then we can use what we just did. We can multiply the square root of 7 here to get square root of 49, and the answer has a 7 in the bottom, no square roots. But you can't just multiply it by the denominator. You also have to multiply the same thing in the numerator in order to not change the value. 6 times 7 is 42. So this is the square root of 42 over 7. Let's do another one. Very similar. Square root of 4/5. So let's break it up. This is square root of 4, which is 2, and the square root of 5 in the denominator. Multiply because we're trying to get rid of the square root in the denominator, you have to multiply by something that will produce a number you can take the square root of. Square root of 5 times square root of 5 is 25, and the denominator then in the answer has no radical. 2 times square root of 5 just becomes 2 root 5, and that's the numerator. That's the answer in the numerator. Let's do something with some variables. Okay, so square root of 5 over square root of 3w. You can multiply the square root of 3w to both the denominator and the numerator to not change anything. But when you do it to the denominator, all of a sudden you get 9w squared, which is actually something you can take the square root of. Now notice, I don't have any absolute values here because I believe it's not required in this today. You know what? I'm just going to, because I feel like it, I'm going to just go add some absolute values. Absolute value, absolute value. Just because I don't remember if the instructions say you need them or not. So you remember the rule is even, odd. So 2, 2, 1 needs absolute values. Let's take a look at the next couple of examples. All right, move the head. Right. So 9 over square root of 5z. Very, very much like the last one. If you multiply the denominator by square root of 5z, then you'll get something that you can take the square root of. And I want absolute values here too, just because I'm a little neurotic about it. I don't know if you're going to need absolute values in the Alex lesson. I will have the answer for you by tomorrow, or by the time we actually meet in class. So we got 9 root 5z here, and that's just in the answer, and then 5 absolute value of z here. Next, cube root 5 over 2. It's this, the big thing that's changing here is that we're not in square root land anymore. We got cube roots. So square root of 5 over cube root of 2, let's separate out the fraction into a numerator and denominator. And now, notice it's not identical. Like here, it was 5z, because you need a square root. But if you just multiply by cube root of 2, you'll have the cube root of 4, which you actually can't take the cube root of 4 very easily. But you can take the cube root of 8 very easily. So you have to think to yourself, what do I have to multiply the cube root of 2? What do I have to multiply 2 by to get up to a perfect cube? You have to multiply by 4. 2 times 4 is 8, and 8 is the number you can take the cube root of. So cube root of 4, 5 times 4 is 20, 2 times 4 is 8. Great. Now you can take the cube root of 2, and there it is. And actually, 20 doesn't have any perfect cube factors. 8 doesn't go in perfectly into 20, so you can't factor out an 8. And the next perfect cube is 27, so it's just too high. So this is the answer right here. You can't simplify it any further. You can't, for example, try and cancel the 20 and the 2. It doesn't simplify down to 10. No, you can't do that. Just keep it the way it is. Boom. Let's do another one. Another perfect cube. All right, so 4 times what? 4 times some number is going to give you 8, which is a perfect cube. I know, it's 2. 4 times 2 is 8, and you can take the cube root of 8 to get this. Multiply the numerator and the denominator by the same thing, you get 7 cube roots of 2 over 2 in this answer. Let's do another. 4th root. Okay. So again, this is a fraction. Let's split it up into a numerator and denominator, and think about them individually. 27. Gosh, what? We need to multiply 27 up to a perfect 4th. And so that means, what are the perfect fourths? Well, 2 to the 4th power is 16, and 3 to the 4th power is 81. So I can multiply 27 up to 81. You can see here, 81 is a number I can easily take the 4th root of. Not easily, but there's like no decimals. 27. So in order to get from 27 up to 81, I need to multiply by 3. In order to get from y up to y to the 4th, you need to multiply by y cubed. There's 1y here, there's 3 y's here that I'm multiplying, and so therefore, when I'm finished the multiplication, I get 81, which I can take the 4th root of, and y to the 4th, which I can take the 4th root of. So that's what I need to multiply the denominator by, the 4th root of 3y cubed. But I can't just do it to the denominator, I also do it to the numerator as well. So we can see that this 4th root of this and 4th root of this, they can multiply to get 4th root of this, 6y to the 3rd. Now when I take this, this is even, odd. I don't know. I think I need an absolute value here, but I think I'm just going to let it go. No good reason why. I just have this sense that that I won't need to. In the instructions, I think it'll assume positive values. I just couldn't help myself. It's an absolute value here, unless instructed otherwise, because the rule is even, odd. 4, 4, 1. We need absolute values. All right. Next one. So we got this here, 3x to the 5th, cube root of 3x to the 5th. So we need to multiply 3 up to a perfect cube. Then the easiest perfect cube to multiply up to would be 27. So as you can see here, and x to the 5th, easiest perfect cube you can multiply up to from x to the 5th is going to be x to the 6th. Because, as you can see, the cube root of 27 is 3, and the cube root of x to the 6th is x squared. That's 6 divided by 3 is 2. But you can't just multiply the denominator by this without also multiplying the numerator. So you can see here we got 5y to the 5th cube root of 9x. And actually, I'm just going to stick them right together. There's multiplication right here. It doesn't make any sense to try and combine the y's or the x's or the 5s or the 9s. It's just going to be like that. And that's the simplified version. All right, now, second half of this. What does it look like to rationalize a denominator when it's a binomial? Everything on the first half of this lesson was a monomial, but now it's a binomial. You can see there's two terms right here. But before we head to that, I just wanted to let you know that my favorite kind of fries. There's lots of fries out there, but my favorite is going to be loaded fries, and a very specific kind of loaded fries. I was in 12th grade, I worked in a deli, and they made these amazing loaded fries. You put the fries on the bottom, and then steak meat, and then cheese whiz, and then lettuce, tomato, onion on top in that order. And I don't know how it sounds to you, but it was absolutely amazing, and I highly recommend. There's lots of loaded fries out there, and I want you to tell me about yours if you got it. Or tell me what your favorite fries are when you get to class. All right. Binomial. So what we've got to remember from, if you want to do this, is we have to remember about multiplying conjugates. Conjugate a plus b and a minus b. These are conjugates. You have the same terms. You're just adding the one conjugate and subtracting the other conjugate. Of course, remember when you FOIL this out, you get a squared minus b squared, and therein lies the thing that allows you to rationalize the denominator. So here you've got 8 plus 4 root 2. The conjugate is 8 minus 4 root 2. You're focusing on the conjugate of the denominator. But of course you got to multiply the same thing in the numerator as well, like we've been doing all lesson. So what you got to do is figure out what that looks like. 5 times this entire numerator. I'm going to put it in parentheses and I'll distribute it later. But you can see here, this is a plus b, a minus b. So then the answer, when you do this, when you FOIL them out, it's going to be a squared. That's 8 squared is 64, minus b squared. 4 squared is 16, and the square root of 2 squared is 2. So, and then, yeah, we can distribute the 5 to the 8, you get 40. 5 to the 4, you get 20 root 2. And so then this becomes 64 minus 32 is 32. You can take one more step here, because I noticed that all the terms, the 40, the 20, the 32, they're all divisible by 4. That's the greatest common factor of each of these three terms. You can factor them all out, and they cancel. And then this is it, 10 minus 5 root 2 over 8. If it weren't true, if you can't just cancel the 40 and the 32, you have to cancel all the terms, 40, 20, and 32. Okay, let's try that again. So we've got this here, 7 over square root 3 square roots of 2 minus 1. Notice we got a minus b, a plus b here. Those are conjugates. And we love conjugates because when you multiply conjugates, you get a squared minus b squared, and no middle terms. So here we've got, let's take this. A is 3 root 2, b is 1, and so then this is going to be a squared, 3 root 2, this is 3 root 2 squared right here, because 3 squared is 9, and square root of 2 squared is 2. And then b squared is 1 right here, this is 1. And then this times all of this, make sure you use parentheses and distribute the 7 to both of these terms. You get 21 root 2 plus 7. And then 9 times 2 is 18 minus 1 is 17. And that's how you do that. Again, multiplying by conjugates. Oh, wow. So let's focus on the conjugate of the denominator, because that's where we want to clear the square root out of. So root 5 plus square root of 3, and that the conjugate is going to be root 5 minus square root of 3. And we have to multiply the numerator by the same. So this is going to be a plus b times a minus b is going to be a squared minus b squared. That's 5 minus 3, which is 2. But this is a minus b times a minus b. This just happens to be the same terms. It happens to follow a formula. We know that a minus b times a minus b is going to be a squared minus 2ab plus b squared. So this is a squared is 5, b squared is 3, right here from the square root of 3 to the square root is 3. And then 2ab, if you multiply a times b, you get square root of 15. So that's what that is. And there are some like terms you can combine. 5 and the 3 give you 8, and this stays, the subtraction stays on the minus 2. So there it is. Oh, and you can take it one step further because there is a greatest common factor between the 8 and the 2 and the 2. You can factor a 2 out of all of those and you just get 4, 1, and 1. So this is going to be basically be 4 minus square root of 15. Let's keep on going. All right. So, very similar idea here. You got a minus b. So let's multiply it by a plus b. That'll give you a squared minus b squared, which is 9. This is a plus b times a plus b. That's going to be a squared plus 2ab plus b squared. And so therefore you can say that adding the 11 and the 2 you get 13, and subtracting the 11 minus 2 you get 9. And I want you to tell me what number is out here in front of the square root. Let's do something with variables. No big change really. It's just going to throw in some more variables here. So we multiply by the conjugate of the denominator. This is a plus b, this is a minus b. When you multiply them together you get a squared minus b squared. For a squared, if a is equal to 4, then a squared is 16. If b is equal to 2 root v, then b squared is going to be 4v. Ooh, this should not be v squared. It should be just 4v. There we go. And this for the same reason. Okay. So we've got, so then you can multiply negative 7 times 4 to get negative 28, negative 7 times negative 2, or minus 2 to get plus 14 square roots of v. And then 16 minus 4v is here. We notice that all of these numbers are even. You can factor out a 2, so from all the terms. So they all get cut in half, and this is your answer. Let's do it one more time. A minus b, a plus b. This is a squared minus b squared. And you distribute over here. Negative 3 times 4 is negative 12. Negative 3 times 3 is minus 9 here. And there's no greatest common factors between all the terms, so just leave it the way it is. And that, my friends, is your lesson. Thanks for sticking with me. Look forward to seeing you in class, and take care.